This is the original interior rear view mirror with auto dimming feature. It is defective as the liquid crystal layer inside has leaked. The replacement electrochromic mirror comes from a donor car. I ditched the plastic parts as they were scratched and opted to replace the internals instead. Apparently, the replacement mirror was previously repaired. The adhesive compound is not adhesive anymore, and there are traces of a quick and dirty job. Nothing I cannot fix though. I removed the metal connection bracket from the old mirror. I plan to use it with the new mirror as it is in better shape. The connection bracket has to be carefully clipped to the mirror in order not to break the fragile electrode that it's made of a fine metallic powder deposited directly on the mirror extremity. Up next comes the soldering of the electrical wires and their respective connections. To protect the connections, I used heat shrink tubes. All done. Looks like this. I improvised the testing harness by using the connector that I removed from the old mirror. Only two wires are interesting, the plus and the minus. And I located the connector here, and the interesting pins are ignition and ground, basically plus and minus. There are a couple of other pins such as reverse, D/S minus, D/S plus, and light. Those aren't interesting for the test. I will program the power supply to provide 12 volts and 0.5 amps like this, and I will connect this thing here. Now it should work, and the mirror will dim quickly. It basically becomes a dark tint of blue, and then it quickly goes quasi-black, allowing the light to hit the sensor will actually reverse the dimming function, so the mirror becomes bright again. Let's do this again, covering the sensor, blocking the light. I'm simulating nighttime conditions like this. And as you can see, the mirror turns black. Well, actually, if I cover the sensor more, then the mirror turns even darker. If I cover it less, then as you can see, the mirror becomes a bluish tint. Removing my hand completely from the light source actually brings the mirror to a complete clear state. Let's do this again. So gradually moving the hand over the light source, you can see now it's blue, and completely covering the sensor makes the mirror to turn black. Alright, now let's complete the assembly. This is the outer case of the mirror. I don't know that if I mentioned, but it's made by Donnelly Electronics. It's written right here. It's an OEM part, and it has the Audi logo printed here. And here is the connector that goes to this connector, which goes to the wiring harness of the car. There are no screws involved into the assembly of this mirror, but there are some plastic tabs instead. There are 3 in the upper side, 1, 2 on the extremities, and 4 on the lower side. 2 here, 2 more here. Next I will connect the mirror controller to this connector. Like this. And now I will try to align the plastic tabs with their corresponding places on the mirror, like this. And then just pop the thing in place. 1, 2, the extremities, and the lower side. This one goes a bit like this, and there is one more part here which will pop like this, and that's the mirror completely assembled. You can see that it's not uniform here. The spacing is a bit higher than here, but I suspect this is due to heating and cooling cycles and extreme temperatures in the car during the summer and during the winter. The mirror attaches to the part that's glued on the windshield via a twist and lock mechanism. There is quite some force required to twist the mirror completely. Once the mechanism locks out, the mirror is secured. I connect the mirror assembly to the car wiring harness. I carefully install the fragile plastic ornament that covers the wiring. The space is a bit tight, but with enough patience, I did it in no time. Be careful not to damage the hood liner. Insert the contact key and switch on the electronics. It is not necessary to start the engine. Cover the rear light sensor. The mirror reacts immediately by dimming accordingly. Job complete.